Hi everyone, my name is Andrew Lee from the University of British Columbia. Today I will be presenting our work, shinyRGT, and our Shiny application for the extraction and analysis of rat gambling task data. This is work done with the Winstanley Lab in the Department of Psychology with Georgios Karamanis, Tristan Hines, and Catherine Winstanley. In life, we face many choices. We make many decisions throughout the day without breaking a sweat. But the most complex choices we make are when the clearly better choice comes at a cost. So, for example, you have to work harder for it, or it comes with a delay. Or for the topic of this class, when it comes with risk, uncertainty. These type of decisions are tricky to navigate because we have to do the cost benefit analysis and think about the future as well. In the mid 90s, Antonio Damasio and Anton Bashara created the Iowa gambling task, designed to simulate real life decision making to understand the neural basis of risk reward decision making. This is a payoff scheme for the IGT. This is the user interface for the task. Through this work, brain imaging studies, and neuropsychiatry research, we now know that the risk reward decision making seems to be mediated by the prefrontal cortex, the amygdala, and the accumbens. These studies in the human population has revealed a lot. It tells us what systems are involved, but it can't really help us understand the underlying mechanisms of decision making. For this, we turn to animal models. The Winstanley lab has been using an assay called the rat gambling task, which was derived from the human Iowa gambling task. This assay has rodents choosing between different choices that differ in terms of magnitude and certainty. Rats are in an operant chamber and are given 30 minutes to conduct the task. If they win the round, they get sugar pelts and an audiovisual cue, which essentially mimics slot machines in a casino. If they lose a round, they are the built. If they lose a round, they have a timeout, and they cannot continue until it is over. They are presented with four choices. Options 1 or 2 are called the optimal choices because they will almost always get a small reward. They win a small amount of sugar, and they get a small and basic audio-visual cue. They rarely get a timeout, but when they do, it's for a very short period of time. As my professor used to say, this is the safe Canadian savings bonds option. Options 3 and 4 are the large but risky options because they may or may not get the larger reward. If they win, they get a lot of sugar pellets, they get a more complex and a longer audio-visual cue. However, the timeout punishments are much more frequent and harsh. As you can see at baseline, majority of the rats are rational decision makers, and they greatly prefer the optimal choices P1 and P2. Note the y-axis on P2. In our group, we manipulate different brain regions and see how this affects the performance on the task. So previously, our lab was using a combination of many different softwares to extract the tidy data. This is not ideal because of the need for multiple programs, which all cost money. As well, this process was very redundant and time-consuming, as a lot of copying pasting was needed to generate the clean data. As such, I wrote a R script to clean and tidy the data, which I later used as the backend for the Shiny app. For this app, I only use tidyverse packages to read in, to wrangle, and to visualize the data. So this is what the raw data looks like. That's generated from the rat gambling task software. As you can see, it's quite messy. It's quite large. There's a lot of Boolean values that don't really mean too much. So we need to create new variables to analyze the data. Such variables include the percent choice for each option, the number of premature choices, and the total score. Now I will show you the functions and usages of this app. The main purpose is to quickly and easily extract and clean the RGT data for researchers that use this assay so that it can streamline the research workflows. To use this app, simply access it through my Shiny server here. You will be greeted with this introduction page. Just go to the data wrangling tab, upload the data, so the messy data here. It will automatically clean and generate a CSV for you to download. So as you can see from this data set, it is clean and understandable. So we have your P1, P2 choices here. We have omission, premature choices. So as you can see from the messy data, this is what we had before. So if you have different sexes in your study, you can add that quite easily. So by default, they will be all females. So let's just say rat numbers 1, 2, 3, 4, 5 were male. As you can see, a new column was created, and 1 to 5 are male, are labeled male. So let's look at 92. So they're female. And our lab uses dreads quite often, which is a method that can inhibit or excite different brain regions. And you can add that data quite easily as well. So you can have HM3 virus, which let's have 1, 2, 3. Let's just say those 3 had HM3, and then 6, 7, 8 has the HM4. So yeah, it creates a new column. So HM3 is here, and then let's find HM4. Oh. So the others will be control. So we have HM4 here. And lastly, you can add the transgene column. Let's just say 1, 2, and 64, the last one, are transgene positive. So that means they're expressing the virus in their brains. So positive here, and should be positive down here. Yep. And then the rest should be negative. Yeah, there you go. Lastly, you can choose what kind of data set or what kind of data format you want it to be. So this is currently it's in long form. You can have it in wide form. So as you can see, it's very, very wide. You can group it by sex. As you can see here, group by virus, group by transgene. Then using the new clean data, you can go to the data visualization tab to create a plot using ggplot2. This was designed with RGT data in mind, but as you can see, it works with other data set as well. By default, it fires up the mtcars data set. This tab uses the grammar of graphics principle to prompt users to generate the plot. The most important aspects of the graphs will be most prominent for the user, and the other aspects can be added later. So most importantly, you need to add data set. So we can add that here. And then I want to recreate the plot that I had in my PowerPoint. So I had session on the x-axis, and then I had P2, so percent choice for P2. It was grouped by virus. Let's make this a little bigger to make it a little easier to see. I had a line, a geom line, and then I faceted by sex. So here's how I created the plot. So let's just add a title. Here we can add a title to the plot. And we can add a sub title as well. And then for the x-axis, it is sessions. And then for the y-axis, it is the percent choice for P2. I'll keep this empty. And then you can change the theme as well. So I quite like the minimal, so I'll keep that. And then lastly, you can fit a best fit line as well. So this is for simple linear regression. You could add generalized linear models as well. And then you can save the plot here, or you can download the code that generated the plot as well. Yeah, thank you for watching the video. I hope you enjoy this app, and I hope this helps researchers that use RGT. Feel free to email me if you have any suggestions or if there's anything wrong with it, or if you just want to chat.